So let's bring our spotlight in. I will go over the spotlight. We'll talk a little bit about the point light, but the spotlight really is my favorite, as it's a lot more efficient maybe than the point light, in the sense that it only throws light within its cone. The point light will throw light in all 6 directions and will require more processing power. I'm just rotating the spotlight a little bit so that it shines onto our little totem here. Make sure it's sort of lined up more or less. Actually, I'm going to throw a shadow that's more behind. And so you see here, first of all, the intensity. So the intensity is in lumens. I'm not 100% sure on how. Here it says 1700 corresponds to a 100-watt light bulb. Of course, it also depends on our exposure and all the other lights. So it is maybe to be taken with a pinch of salt. Not maybe 100% accurate here. But one thing that's always worth tweaking is the attenuation radius that is going to, so if I zoom out, and I'm going to hide my outer box so that I can see what's going on, you will see that this light will throw light very, very far away. But at the same time, although this attenuation radius is quite long, you see that now the end of the light is far from the object, but the object has hardly got any light whatsoever. So I'd have to increase my intensity drastically if the light was that far. So that's a little bit maybe unrealistic. So I will keep this attenuation radius, but try to have it so that there's a gradient that will appear between the top of the light. This is what I usually try to do, so that there's a gradient from this brightest point to the floor here. There's a clear attenuation happening. Maybe have it the light so that it will, I'll take my snap off, so that it will be like we've got it in the Airco catalog, hanging from the ceiling. So the attenuation can be a little bit further, but then you'll see that it becomes quite flat here all the way down, and becomes maybe slightly unrealistic due to the floor being lit evenly. So I'll change my attenuation like that, and like that. The inner cone angle is rightly set at 0. This is the way to use the spotlights. That again, we're looking for this very soft transition from the center to the edge. If I were to move my cone, my inner cone, right near the edge, then again we end up with this very flat area, which is not wrong, but it's less attractive, let's say. Okay, so going down the settings a little bit, the source radius is something that I don't really use very much, but I wanted to show you this looking at the specular highlight here on this ball, and this is what the source radius is going to help us do. You'll see that as I'm moving the slider up, the size of this yellow ball is increasing, but what it's really doing is changing the size of the highlight on the ball. Okay, so that's giving us a little bit of control over that. The source length, on the other hand, is going to change the shape of this highlight. So it's a little bit like in the shader. If you use 3D Studio Max, we would have an anisotropic material that will mimic this elongating of the highlight. Now, if I go into very high values, you see that it just completely throws the shadow away. So it's just plain wrong there. Okay, these are settings that I don't necessarily play with very much. It's mimicking the area to use a spotlight as an area light, so we don't have these kind of such sharp little highlights. Okay, the temperature is a very useful little slider because it allows us to warm or cool our lights, and whereas the light color here will just allow us to throw it into all sorts of different colors. Here it's really whether we want to have a cool light or a warm light, well, the opposite, a warm light or a cool light. So, but I'll take that off for now, because you see that what's happened with our post-process volume is that because we've modified the white balance ever so slightly, this, if I keep it as its default, it looks quite white, the light looks quite white, and if I warm up with the white balance, the light becomes warmer, and my blue here is going to appear warm as well, or more neutral. If I put it on the other side, on the other hand, we get the opposite. So this is great to control the warmth of the light. Of course, we can warm them a little bit, and I tend to do that, but for that the temperature is great. So let's do that. We have a little warmer light here, and you can see I've got my preview here. So just like with the I'm just going to put in the cone at 0 here. With the spotlight, it's the same effect as with the sun, but I tend to have them on movable. Again, this is something that is up to you. It obviously decreases the amount of render time when we press on build, but it takes away some of the bounce lighting from spotlights. However, I think it's sometimes worth losing that for the added flexibility of being to turn your lights on and off during the game, and allow that flexibility for the interactivity. So I'll set them on movable, and obviously that will allows us to not have these messages every time we move our light or change a setting. The indirect lighting intensity here, that's going to, obviously if we've got it on movable, that's going to be redundant. And the volumetric scattering intensity, we'll have a little look at that when in the volumetric fog setting. Okay, if we go down here a little bit further, we see this inverse square fall off. So that's what our attenuation radius is going to be dependent on, as this gradient that will go from bright to dark, you can see here, is very nice, very realistic, will be controlled by the inverse square fall off. And here, and so this inverse square fall off is the way the light will diminish based on real light values. So this is something that's constant. So for any interior lighting like this, it's wise to just keep that on. I've used spotlights to mimic floodlights before, and for that I wanted to turn that off. It wasn't practical to have such high values, and the inverse square, the fall off, was not something that I desired. I wanted something very flat, like a stadium floodlight. So in that case, one could turn the inverse square fall off. Okay, so now we've got this whole section here on shadows, and we've looked at shadows a little bit with our sunlight, and here we've got very similar situation where our shadows are looking a little bit rough when we get close. From far away it's fine, but when we get close we would like to have maybe a little bit more precision on that. So we can increase the scale of our shadow map, but you can see that it doesn't actually do very much here in this instance. It does when I reduce it, so it's good if I to create very soft shadow, and this is giving me the resolution. This is controlling the resolution of a shadow map. So this is creating a shadow image, effectively a shadow texture inside of the light, and this is controlling the resolution of that image. Now, why does it not do anything when I increase to 8? Well, there's a little tip here when it says shadow map resolution is still clamped by r.shadow.max resolution. So we need to increase that if we would like to have our shadow more precise. Okay, so the way we do that is that we need to bring up the console. So that's on my keyboard is the key that's to the left of number 1. And if I press it, the console is going to appear. And so that very simply, we can just type r.shadow.max resolution. So now I can just click that, and I'm going to set that to 4096. And you see that as soon as I press enter, that shadow became more precise. I'm going to do it again, r.shadow.max resolution, and if I put that on 512, you see that's gone all blurry again. All right, so I'll just set that again, shadow 496, and that's got more precise. So from further, we can see we lose a little bit of the indentation in here, and we can play with higher values, and that's going to give me much sharper shadows. Here we don't have any self-shadowing problem, and that's where we are shadow bias. So if I bring my shadow bias down, you will see all these little lines, which effectively is the problem that we have when the bias is too low, and it's giving us the object is casting shadow on itself, which is not very good. The value of 0.5 here works very well. If we have contact shadows problems like we've seen before, we'll need to maybe increase, if we have self-shadowing problems, we'll need to increase that, and if we have shadow contact problems, then we'll need to decrease it. Okay, this shadow filter sharpen I don't use very much because as you can see, it's done, it makes it very, very sharp, and I tend to try and soften shadows more than anything. So and these contact shadow lengths don't seem to work very well for what I ever need to do. Okay, so the dynamic indirect lighting, we've seen that, and that's for the GI, and all the other points here are used for the whether we want to cast shadows or not. So we'll leave those on. The volumetric shadow, of course, will be for the volumetric fog. Okay, we've seen the area shadows for stationary for the light mass with the sun. It works exactly the same, but again, I'll remind you that here, because we've set the spotlight to movable, we're not going to want to have that on, because it's not going to be rendered inside of the light mass. Okay, so this spotlight is very, very versatile. I will, in the next video, I'll show very simply how we can turn that into an IS light.